One more example, that's a very sad story. So this bird is called a passenger pigeon. Once passenger pigeons were very abundant in North America. So I don't know, they gathered in huge flocks, millions or probably even billions of individuals. But now the bird is extinct. And the reason is that this was a very social bird. A single colony of passenger pigeons had to have a certain population. So, and if population is below a certain threshold, then the I don't know, the birds became so sad that they just stopped breeding, and the colony would die out. And by the time people realized that the bird is about to go extinct, there were still sufficiently many of these birds in existence, but there wasn't a colony large enough that is above this threshold. And then everyone died out, and it was very sad. And it happened recently, so here is the last surviving passenger pigeon, and it died in, I think, 1930s or something. Right, so the idea here is that if we want to model it with a differential equation, then on the ty plane, we introduce two thresholds, right? So the threshold above which everyone dies out, and another threshold is the carrying capacity, right? So this is K, this is T. And the idea is that now, if the initial population is above the threshold, then the arrows point upwards, so the population is growing. If it is below K, then it is decreasing towards K. But here, if it drops below T, then everyone dies out. And in order to model this, we introduce this type of the right-hand side. Or if you look at it carefully, you will see that indeed the right-hand side of this equation has 3 zeros, right? One of them is 0. From here, if y equals t, then this part is 0. So this is t, and this is k. And then again, if you analyze it carefully again, and you will see that if y is bigger than k, then the right-hand side is positive. So, oh sorry, the right-hand side is negative. If it is between t and k, then it is positive, and so on. And hence you have something like this. So here you have two thresholds, and that's exactly what I mentioned. So you have 0 here, t here, and k here. And now you can see that this is a stable equilibrium. 0 now is also stable. But the other threshold is unstable. Right? So this is an unstable equilibrium. Because here, in the neighborhood of this equilibrium, the arrows point away from it. So all the solutions drift away from it. And since this equilibrium is unstable, well, because of that, roughly speaking, the passenger pigeons died out.